Today is February 17th, and we're doing our business math. We have some questions on Chapter 3 that I'm going to work out, and then we have a couple of questions on Chapter 4. So what I've asked the students in class to do is to shout out if they have a question. If I'm going too fast, I'm going to go pretty fast because I want to get all of this on film and post it up to our Moodle page, and then you'll have it as a reference, and you can play back anything that I blurted too quickly. So, having said that, let's take a look at our web page for just a second. If we take a look at where we are on February 17th, what you will see is that last week we did not have a class meeting, but I did some work on a couple of problems on Chapter 3, and then we begin today with Chapter 4. So the first thing I would like to do is to go back through questions that the students have on Chapter 3. So tell me the first problem that I should take a look at. Okay. Oh, you can just tell me the numbers, and if it's bottom line or self-check. Oh, 11? Should we start with 11? Okay. This is on the self-check.
Yeah, it was right before, so it was pretty easy, actually.
Oh, good. Good. All right, let's see. Oops, I better, since nobody can see that, let's...
Oh, actually, I have one, actually. Can we do the 3.4?
3.4? Sure. On the self-check also?
No, before, but I didn't want to look at the answers and stuff.
On the bottom line?
Yeah.
Recognize the numeric relationships?
Yes.
Okay, let's do that. 3.4 bottom line. All right. So what we have here is we're looking for patterns. And the first one is 4, 7, 6, 9, 8, 11. 4, 7, 6, 9, 8, 11. And then we want the next two numbers. And after that, we have 12, 48, 24. 96, 48. And we want the next two. All right. Now, there's a couple of things. Is that sometimes the pattern is a variable. In other words, you might have one pattern between these two numbers and one pattern between these two numbers, and then these two, and then something else happens in between. So in other words, when I look at 4 and 7, I think 4 plus 3 is 7, right? And then how about 6 and 9? 6 plus 3 is 9, and 8 plus 3 is 11, right?
Oh, that's how you do it.
Then look what happens in between. 7 to 6 is minus 1. 9 to 8 is minus 1. So that means if I go plus 3, minus 1, plus 3, minus 1, plus 3, this is probably minus 1, which is 10. And then this would be plus 3, which is 13. See how that works? Now, and a trick, it's not really a trick, but I always look at the numbers to see if they have something in common. And with this, when you have numbers that get bigger and smaller, it's not always the case, but when you have, if they keep getting bigger, it can tend more likely to be one relationship. But when you have bigger, smaller, or if the numbers don't continue getting larger or smaller, there tends to be more than one pattern. So that's sort of what I would see here. Now here, the first thing I see with these numbers is they all have 12 as a factor. In other words, this is 12 times 1, 12 times 4, 12 times 2, 12 times 96 divided by 12. I think it's 8, but let's find out.
So plus
8.
36.
12 times 8 and 12 times 4. Yeah. So what I kind of see here is, okay, 12 to 48 is times 4, right?
Okay, so you don't, that one you don't do like plus sorry to do it by hand, like plus 46.
Mm-hmm.
Minus 24
Right?
was
Yeah.
or 74 plus 74.
Right. But it looks more like a multiplied, and the reason I say that, it's hard to see this, but if you look at like 96 is much, much larger than 24, so the differences aren't the same.
Also, you
Multiply, yeah, it kind of looks like a multiply
Okay,
to
I
me.
was additioning.
Right.
Did I change something?
Right. You're like, what? Yeah, I know, and it's sort of a strange thing because I don't really have a particular.
Okay, if I do this, it's like plus 46 minus 24 plus 74 minus 52.
Yeah,
Then
and see, there's
what's
just too much. It's just kind of going, all over the place. But look at this. If you multiply this by 4, and you look at this, 24 to 96 is also multiplied by 4. If you go from 48 to 24, that's divide by 2, and 96 to 48 is divide by 2 also. So I think the pattern is times 4 divide by 2 times 4 divide by 2. And then times 4 would be 48 times 4 here, which is 196, I think. 8, 9, 16, 32, 192, sorry. And then divide that by, I have to check my number here, 48 times 4.
So divide by like 4? No.
And then divide by 2.
Oh, by,
Mm-hmm.
okay.
And then you get 96. So the other thing is, you notice, is that 48 repeats on the third, and 96 repeats on the third as well.
Okay, I'm confused. I'm sorry.
No. It's very difficult. I mean,
So, just out of curiosity,
Yes.
when would we use this?
Ah,
I can roll
right. No, those are, you can look for these, like, if you were, this is actually some pattern, not a particular pattern, but looking for patterns can help you with, like, anything with genetics, for example, like breeding characteristics in. Also, bacterial growth follows a pattern like that, where if you have one bacteria, it splits into 2, and then the 2 split into 4, and the 4 split into 8, and so it gets bigger in a hurry, right? So that's when you can they use those kind of patterns to, like, identify where outbreaks of things occur. Those are some ideas. Yeah. Looking for patterns also in other things. This sounds like a silly example, but let's say you said, and once again, I won't use your names on camera, but like you drove to Billings and it took you 2 hours, and you drove to Billings and it took you 3 hours. What could you say about your speed? Because Billings hasn't moved, right? Right. She's driving half again as fast as you, right? Basically. So finding patterns, another thing that you find patterns in is geology. Like when you look at rocks, when you look at the way they break off, you can determine, it's like one of the tests for what it looks like, and it's based on patterns of the crystalline structure. Wallpaper is another one. If you're matching up wallpaper, I don't know if anybody wallpapers anymore, but I do. So, right, exactly. So if you don't line it up just right, you can just see, like, that's just weird right there. So, pattern recognition, or another pattern, which is one that I use a lot, is like if you're using a recipe and the recipe is for 4 people and you want to make it for 8 people, what do? You double everything, or if you're making it for 3 people instead of 4, I would just make 4 and let everybody have a big portion. But theoretically, right? Like, how much you would use of one thing compared to another thing, that sort of thing. I find this pattern and there's a couple of problems. I find this to be a little distressing, to tell you the truth. I think this is a really tough pattern to see through. So, and the other thing about patterns is, if you find a pattern that works, you found the pattern that works. Like, you could call this something else. You could say times 4 times 4 times 4 divided by 2. Or you could say this times 2 is this times 2 is this, so this times 2 has to be this. Do you see what I mean? So it's the same idea, but if you get one, there's more than one way to express most patterns, especially the more complicated the patterns are. So if I were to say times 4 divided by 2 times 4 divided by 2, and you were just to say multiply by 2 every other number, you're still going to get the same, it's still the same pattern. So, yeah. But I do find that to be a very complicated pattern. So, should we take a look at number 11? Is that the next one? All right. How long would it take to travel 1,265 miles at 55 miles per hour? Okay. 55 miles per hour is the speed, right? So what that means is, like, if you were going 110 miles, it would take you 2 hours, right? If you had to drive from here to Billings, and Billings is 110 miles away, if you drive 55 miles an hour, it's going to take you 2 hours. But this time you want to travel 1,265 miles. That's the distance. And you want to find the time. Okay? So the formula is that distance is equal to the speed multiplied by the time. Okay? That's sort of like the universal pattern, which means my distance is 1,265 miles equals 55 miles per hour times the time. Okay? Now, the way that you would do that then is to take, I'll do this a couple different ways, but if you take 1,265 and you divide it by 55, you'll get the number of hours that it takes. So 1,265 divided by 55 is 23 hours. Now, the other way that you can do this is, let me put it on Excel for you. You could do this by hand, but I'll show you. If you're not comfortable using formulas, let's think about what's going on here. Oh, I got to pull this back over to the podium PC. All right. So we want to know time. So if we just know, if we're traveling at a speed of 55 miles per hour. Oops, let me put speed here. And then distance. And then time. Okay? If we're traveling at 55 miles per hour, if we were traveling 55 miles, how long would we have to travel? How long, if we're going 55 miles an hour and we go 55 miles, how long would it take us to travel that distance? Yeah, 1 hour, exactly. So,
Gotta be simple, 'cause they're both-
exactly, which is what I was, right, I probably making, so let's double the distance. If we double the distance to 110, how much time would it take us at that same speed?
2.
Yes, perfect. All right, so what do you see in terms of a pattern? Every time this increases by 55, this increases by 1, doesn't it?
Okay, so then 165.
Ah,
is equal to
super.
3.
You got it. All right, so now we're traveling a lot farther than that, but let's go ahead and do this. Every time I do this, I want to add 55. So I want to take the cell before it, which is B4, and add 55. Okay, so that would be the next number in the pattern, right? And let's do this. Control C. I'm just going to pull all these down, and still I'm not where I need to be. I want to get to how many miles the problem asks me, which is 1265. Ah, very good. So here, if this is 1, 2, 3, this one must be 4, right?
Yeah.
So I'm just adding 1. And if I copy that down, what do I see at 1265? 23 hours. So once again, there's more than one way to eat a Reese's with this, so to speak.
Okay, but how do you... Where is the question? Can you go back to the question?
Up here?
No, the one before. Was
Oh,
the
sure.
positive.
On my document, Cam?
Yes.
Right here, yes.
Okay. How can you like find the time and I mean, how do you?
How do you break this out?
Yes.
Yes, so if you do this, I'm just going to write this. Distance is equal to speed times time, right? All right, now in algebra, if we want to get the t by itself, if there's something multiplied by it, we have to divide both sides by that thing, which in this case is speed. And so these cancel, and we're left with time on one side. So over here, we're at distance divided by speed. So that's the algebraic way. That's why I did it on Excel as well, to show you. But basically, you take the distance, which is 1265 miles, divide by the speed, which is 55 miles, and you get the time, which is 23 hours. And you can read, yeah, that's it. And you can also check it right here, because if you took speed, 55, and multiplied it by time, 23, 55 times 23 is 1,265. So if you're not confident of your answer, you can go back and check it with your numbers. Very good question. What was your next one, Ariane? 12. Let's take a look. Okay. Bob and Mary start traveling toward each other from 1,330 miles. Bob is traveling 30, Mary's at 40. How many hours elapse before they meet? All right, now I think, all right, no, I thought I had done that one, but I didn't. Okay, I thought I had done that one, maybe I didn't. Oh, I sent it to you on an email. Did I not? Let me look. Let me look. I meant to put it up, but I think I talked about closing speed. It was Emily who sent me that question. Let me see. Oh, I should have done it. There.
So you just divide 1,330.
There.
by
Okay,
30.
right. So if you look on your email, I sent the worked out problem number 12 to you. Okay? So it's, let me make sure I got that. Maybe. Yes. Okay, so if you check your email, I'll post this up on our
Yeah, I
webpage as well.
remember this.
So this one is on your email.
Okay.
All right. Super. Yep. And then number 13, are we doing? Yes. Let's take a look at 13. Bob and Mary start traveling toward each other from this. This is the same type of problem. So if you look at 12, if you look at the word solution in your 12 and 13, you'll be able to do both of those. Okay?
I have questions on 19 and 20 in this chapter.
On 20?
19 and
Okay.
19, I just,
Yeah,
Next.
I'm not quite sure. It's another one of
Oh,
those
it
problems.
is.
Me too.
Pattern problem.
You know what? It's the same pattern. 5 times 4 is 20. 20 divided by 2 is 10. 10 times
So I-
4 is 40.
Got that, but the answer that it gives, I don't understand how it got.
Okay, so let's see.
Because I was timing things by 5.
Oh, it's by 4.
It's by 4.
5 times 4 is 20. So it's like this.
You're right.
See, there you go. So that'll maybe make a difference. And then 1040. So then this is times 4. This is divided by 2. This is times 4.
The thing, 'cause that's what the word
I know. I think it's a very difficult
I might
pattern.
be able to get the multiplication, but then you throw the division in
Yeah.
there, and I'm lost.
No, I agree. I think this is a troubling pattern. I mean, especially for business math. I really do.
Yeah, but I get like the pattern, like divided, multiplied stuff. but
Yeah.
Not how to get the next number, how to get 80. Like you
It's
just
time, right.
multiply by 2 and then you get 80.
The pattern
Oh, no,
goes
no,
by times 4, then divided by 2. I know. So 5 times 4 is 20. 20 divided by 2 is 10.
Yeah.
10 times 4 is 40.
40.
40 divided by 2 is 20.
Oh, you have to apply an over divided
Yes. There you go. There you go.
by 2. So
Mm-hmm.
if you divide 40 by 2, you get 20, right? How do you get
40 divided by 2
Oh, yeah.
is
okay.
20. Yeah. So it's that same alternating
That's
pattern.
Like 4,
Yep.
80. Oh, okay, gotcha.
Mm-hmm.
Okay.
So on 20, I know the first part, because when it says to find the price of 7 items at $1.99, I
Right.
would think $2.
Yes. that's
Perfect.
what I
But then what do I do after that?
Okay,
How do you
less.
get the decimal?
Right, less 7 times
Yeah.
1
So
cent, which is 0.01.
This
Yes.
stuff was actually super easy.
Oh, I'm so happy to hear that. That's wonderful. Yeah,
So
so,
it's the 7 that turns into,
Right.
where do you get the 0.1? That's
okay, 1 cent.
Well, you got like 7 multiplied by 2, so you get 14. Then you take like this, like 0.1 from the 90. Like
That's correct.
7, and you get 13.93.
Right. 1 cent is the same as $0.01. It's 100th of a dollar.
But where do we get 1 cent?
Because if you look at 199,
Yeah.
199 is $2 minus 1 cent. So in other words, they're giving you 2 steps. If you didn't have a calculator, I mean, obviously the easiest way to do this would be 199 times 7, right?
Yeah.
But they're saying, what if you didn't have a calculator? Well, you could say
See, I
199.
didn't even get multiplication out
So
of
Oh.
it's like question 3.5. Like you have 399 by 8
that. I
multiplied
just
by 8.
rounded up.
Yeah,
Because
Right.
I was like, well, you look at $1, so just round it up to $2. So that's all I
But
got
it's
out of
like
that
you
whole
like-
problem.
Right.
32. Like if you put 8 instead of sorry, 4 instead of 399, you get 32. But if you go like 32 minus z, you get 31.92. So you just put the 8 minus. And that gives you. So
I
like-
just don't think I get the whole cents and decimal stuff.
Oh, okay. Sure, sure. So, I don't know if this is helpful or not, but if you think about the word cent, it's like the word century. There's 100 years in a century. So cent
Right.
means 100 or 100th. So,
I just don't see that in the problem.
right. Well, it's not in the problem. What it's
Okay,
doing is
so
it's,
I'm like,
right.
What am I supposed
Right.
to be doing?
Right. No, what they're saying is, and I mean, I think what you're doing is a very direct approach. You're saying, well, if I want to know how many 7 items is, I would take $1.99 and multiply it by 7, right? And then that would be my answer.
Or I just round up to 2 and then.
Round up to
okay,
2
multiply it.
times 7, which is 14, right?
Yeah.
But then on each one of those items, you saved a penny.
Oh, so they're wanting to know what you saved.
Well, if you saved a penny, how many pennies did you save on 7 items? Yes. So you subtract from that 7 cents, and you get $13.93.
You don't mind if I did this by head?
Mm-hmm.
It's like I don't know how to make a demonstration, but I
Right.
just did it by head.
It's good. And you know, sometimes problems like this, I mean,
Well, I struggle with word problems anyways.
Right.
So I was
sometimes
like,
if you put yourself like in a situation where this might happen,
yeah.
like at the grocery store, you know,
Right.
I mean, I've seen people, I mean, I think about that all the time. I mean, but now, you know, I think that this is kind of lost too because a lot of people use debit cards and credit cards. But if you're counting out money, these kind of,
That's
right,
I do
you
my
know.
food shopping with my calculator.
Yes.
Right.
Which is not a bad idea. I'm not gonna lie. I think that's a good idea.
I have
So,
to.
so, but that's what they're getting at is they're just saying
Like, because I got the first part of it, but I didn't
Super,
have that second
right.
part. I didn't know what
Yeah.
they were looking for.
that's what they're saying when they say less 7 times. They mean minus. You know, so they're saying on every item
Right.
you saved a penny from $2. I mean, if you estimate it as being $2, you really saved a penny on every item. Yeah. Does that make a little bit more
A
sense?
little bit.
All right. Yeah.
Oh, I have one last question.
Sure.
With you guys.
Sure.
Can we go back to question 5? So here's what I do, but I'm having a lot of trouble doing this by hand, so I just
yeah.
calculated everything, but I don't know how to write it, so I kind of cheated with my calculator.
Oh, sure. Okay.
How do you?
Yes. All right. So on number 5, okay, Wait, on which chapter are you on? Or-
Three.
3?
I think, which page was it?
Let's see.
No, it's on picture like.
Yeah, it's number 5 on
Oh, it's on after, so that's after.
Oh, I see. You know what I was confused about is because you have points and we tend to use commas. This is not incorrect in any way, but I just didn't recognize the numbers, so I apologize for that.
No.
Mhm. And it's okay. Don't change that up. It's perfect. But
I know this one I cheated. I need my calculator.
so 12, 493, 6007, 3028, 9728. All right, we want to add all those numbers. Now, what we first have to do is to align them, because with, like, if here's our thousands, right? So in other words, this is 9,000, this is 12,000. So the 12, you have to align them on the right. In other words, because these are all my ones. Then I add this up. 8 and 8 is 16, 26, isn't it? 7 plus 3 is 10. Yeah, 8 and 8 is 16, 7 and 3 is 10, so this is 26. You know, no, that's good. So you write down the 6, and you carry the 2. Then you include the 2 in the next add, so you have 9 plus 2 is 11, 12, 13, 14, 15. So you write down the 5, carry the 1. So you have 4, 5, 5 plus 0, 0, still 5. 5 plus 7 is 12. So you write down the 2, carry the 1. Then we add 3 plus 6 is 9, plus 3 more is 12, plus 9 is 21. So we carry that. And 2 plus 1 is 3. So the answer is 31,256. Sorry, that's kind of hiding under the... So yeah, if you always start at the right-hand side of the number and line up the whole part, the ones, then everything else will come off to the side, and then you carry anything that's bigger than 9. You carry the digit on the left to the next column. Yeah, I know, it's kind of, yeah. I don't want to run out of time, and I so apologize for for sounding rushy, but I want to look at chapter 4. So what problem should we start with?
I was looking at 11 and 12 are the ones that I...
Okay. 11, 12, the review problems. A 2-pound box of salt sells for $3.
And I've done this every which way, and I'm like, I am not coming up anywhere near
Okay.
money.
What we want to know is what's the cost per kilogram. All right.
Yeah.
What we need to do, weight or mass is in pounds and kilograms. So we need to know how many pounds there are in a kilogram.
I had 0.453 kilograms.
In a pound. That is correct.
2 pounds.
I was like, you know
Yes,
this.
that's right.
I studied this
That's right.
when we were doing VEC class.
That's right.
Kilogram, the metric system, that's my thing. There you
I was
go.
like, I knew you would do good on this.
So tell me again how many pounds. We can do this.
21 pounds times...
No, 0.04. How many pounds per kilogram? I'm sorry, I did it the wrong way. It should be 1 pound is 0.04 something kilograms.
5.3.
Thank you. See, and you love the metric system. She loves
This
kilograms.
one I
I was
know
like,
it.
she gets that far. I'm like,
I know.
This American system, it's not like I hate it, but I
It's
don't get it.
confusing. Okay, so let's take a look at this before we get started on the math. 1 kilogram is just slightly bigger than 2 pounds, right? Okay, so if 2 pounds costs $3, we're getting a little bit more than 2 pounds. So we should expect it to be just a little bit more than $3. Okay, so that's where we start. Let's do something else. If 2 pounds is $3, how much would 1 pound cost?
1.5.
Yes, $1.50, right? See, so this is kind of a pattern. Do you see why that? Okay. So then, how about this? If we know that 1 pound costs 150, and there are 2.2 pounds in a kilogram, I could just take 150 and multiply it by 2.2, and that would give me my answer, because there's 2.2 pounds, right? So like if you're buying 2 pounds, you know, it's $3. If it's 2.2 pounds, it's just going to be a little bit more than that. So it's going to be 2.2 times 150. Yes.
This is where I'm not getting
Okay.
their
This.
answer.
Okay. The answer is $3.30. So you tell me, and I'll see.
That is not what they put in the answer book.
What did they put?
They put 3,125, like 3.125 or something like that.
Well, that's just
And
ridiculous.
I'm like, how do you round up? Because my answer came out with like $3.03. Well, yeah, I got $3.30.
That's the right
So
answer.
I was like, how do you round up to whatever they want you to round up to?
I don't. You know, the thing is, first of all, I would have to say, money only goes to pennies.
Yeah.
0.125 cents does not make any sense.
I know.
Right.
Okay.
So you're on track.
Okay.
Yeah.
I went a roundabout way of getting that answer.
Okay.
I took 2 pounds times the kilograms, and
Two-
I got 0.906. And then I took $3 divided by that.
So in other words, what you're saying is 2 pounds. Right. You did. That's okay. If you do 0.0453
I came up with like
times 2.
3.21.
Right. 0.0. Okay. If I take this number
Mhm.
and I multiply it by 2 pounds by 2.
Right.
That comes out to be 0.08906 kilograms. So in other words, 0.08906 kilograms is the same as 2 pounds, right?
Yeah.
So that means that this much of a kilogram would cost, that is just too weird. Hang on a second. Oh yeah, it's point. That's not right. This number's
So
not
it's
right.
0.906.
Thank you. I was going to say,
I was like,
but this is
that's not
point.
a-
1 pound is how many kilograms? Tell me again. That's where we have a problem. I just
0.5 or 0.453 kilograms.
0.453. Okay, there we go. Now I feel better. So this is going to be 2 pounds then, is 2 times 0.453, which is 0.896
So I got
kilograms.
0.906 is what I came up with.
0.453, it's possible,
Do you take
times
that?
2. Yep, 0.906.
Okay.
Okay, so that's 0.906 kilograms. Okay, so
So then I took the $3 and I divided it by that.
that's correct.
Okay.
So you take $3 and divide it by 0.906, and you get 3.311258. And as we said, these numbers don't make any sense, do they? Because we're talking about money.
Yeah.
So to do it that way, you're going to come out with 3.31 or $3.31.
Yeah.
Those are essentially the same answers.
Right.
What's really
They
the
just
difference
cut out-
is, right.
yeah. They cut out like the first two and just went with 3.125.
Right.
So that's what threw me off. I was like,
Oh, I get it. I totally get it. So,
Okay, so I did that one.
yay! See?
So I guess, what is my, I don't know.
Is there another one that you? Oh, here's 12.
was the other one, and I put in my notes that I didn't do it right, so I don't know what I did.
Oh my gosh. I'm going to show you this, and it's not, I think that you will like this, but because we're short on time,
Yeah.
I'm going to write it out, and then you may have to puzzle, you may say, where did she ever come up with this? Okay, so here's the deal. We have 2 different conversions that we need to do. In other words, to do this problem, we need to change gallons into liters, and we need to change miles into kilometers. Okay? So, first thing, it says how many miles per liter did he get? Well, he got 1,028 kilometers per 22 gallons, right? but we want to get that in miles per liter. So we want to figure out how many miles this is and how many liters this is. All right.
If I remember, 1 kilometer is 1.6 miles.
I believe you are correct. Let's find out. So I'm going to,
Something like this.
so let's say kilometers to miles. And
There you go.
this is, so 1 kilometer is equal to 0.62137 miles. So if I multiply this by 0.62137,
Oh, I thought miles were more. I thought it was like 1.
did I do it backwards? Hang on a second. No, kilometers are shorter. Yeah. So this would be like that. Okay? Now a gallon, it's the opposite because a gallon is bigger than a liter. Okay? Yeah, a liter is close to a quarter of a gallon. It's not exactly a fourth, but it's close. So if we then say gallons to liters, the number is 3.78.
Okay.
So we multiply this by 3.78541
What are we multiplying by?
liters per gallon.
So we're doing 22 gallons by 3.7.
Yes.
Okay, I did that.
Terrific.
Got that.
Okay, so then if you think about it, the kilometers is on the top and the bottom, and the gallons is on the top and the bottom, so you're just left with miles
Can you flip back to your screen? So
per, oh yeah, I sure can.
Sorry, I was like, I'm not.
We're not doing it. There we are, there we are. Okay, so kilometers, I multiplied by 0.62137 to get it to miles. And gallons, I multiplied by 3.78541 to get into liters. So the top, my numerator is 1,028 times 0.62137, and that number is 638.768. And on the bottom, I have 22 times 3.78541. Whoops, my calculator just died on me, but I'll see if I can revive it for a moment here. 3.78541. That number is 83.279. Okay, so then if I take this and divide it by this, yeah?
You took 83 and divided it by what?
I took 22 times 3.7, that's on the bottom.
Yeah, I got that.
Okay, so then I would take this number, 638.768, and divide it by the 83.279 to get that in miles per liter. 63.768. And that answer, oh, my phone just, I mean, not my phone, my calculators, my batteries are almost dead, so it keeps shutting off on me.
So you put that number in first, right?
Yes.
Okay.
I'm going to have to get my phone.
7.67.
I think that sounds right. Let me see. Let me get my calculator over here. 638.768 divided by 83.279. Yep. So I get 7.67 miles per liter. How does that look? So the deal is if you don't, you can convert the lengths from kilometers into miles, and then convert the amount of gas from gallons into liters,
Well,
and
that's
then you can
crazy
do that.
because I came up with that answer. I just don't know where.
Oh, well, that's a good sign. So,
Sorry.
all right.
Not
Well-
sure. I took like 640 miles divided by.
Okay.
By 83.27 liters.
Yep.
So that's kind of how I came up with that.
I think you're all right. Well, you guys are great. I appreciate your hard work, and I'm sorry for being in such a hurry, but please, I will post this up to the page, and then it will be available. Also, don't forget, I'll be around all day today and tomorrow, so if you need help, come find me. And then email me if you have problems. See the tutors if you have problems. So you
Yeah,
got lots of help.
I was like,
All
oh,
right.
we got class. I'm going to ask before
Yes,
I turn this
absolutely.
in.
No, I'm
Because the
glad you
last one
did.
I just turned in because I was like,
It's done. Well, you guys are great. So